morning, all. Am I audible? I hope I'm audible. If there is any problem, just do let me know. In the last class, we have been discussed about the basics of semiconductor devices, how basically BJT, IGBT, MOSFET are being discriminated from each other. So we saw the difference between them, and we are also seeing some of the properties of thyristors and diodes, everything. So in today's class, let us cover some of the questions which are related to the previous topic that we have covered. And here already we might have seen the basic properties of switches like SCR, that is silicon controlled rectifier, thyristor basically. And in prior to this subject, we have been discussed about circuit theory like network analysis. There we saw one topic is called DC transient. So in DC transient, basically we will be dealing with the transient effect of inductor and capacitor. We saw how they are basically behaving to the DC source when the moment they are instantly connecting with their DC supply or they are suddenly disconnected from the DC supply. So we have done variety of things. For inductor on the DC supply, suddenly connect panna, what will happen inside the inductor? Same thing we saw for capacitor also. Now, here you should keep these things. This phenomena, whatever that you have observed in network theory, circuit theory, just we saw, just we understood the properties of inductor and capacitor. Now it is time to explore your knowledge. It is time to see the application of this transient effect. So basically, in our power electronic switches, when the moment I am calling it as power electronic switch, switch in the sense what in transient, everywhere we have seen this effect. When we are closing the switch, what will happen? When we are opening the switch, what will happen? After opening the switch, after a few seconds, what will happen? So these types of things we have been observed in transient. Basically, this is called a transient effect. Now, what we are doing in power electronics? Are we doing the same thing or not? Yes, sir, of course, we are doing the same thing. So, it is very important to understand this transient phenomena in a proper way because other questions that are being taken from the power electronics are very easy. Like easy in the sense direct questions. There are some questions which will be related with the transient effect. Now you should understand, it's time to understand or explore the knowledge of transient effect in power electronic switches. Let me bring some of the questions which are related to transient effect as well as power electronics, which are related to power electronic switches only. But during the switching operation, how they are behaving, how the transient effect is being observed in the outside. Don't think too much, but just have a capture, just have a look in your mind itself. No need of notes at all, because in transient there are no big things to memorize. These are very few things that we need to keep it in your mind. I don't think that's a difficult thing. We have seen already all those. So just keep smile in your face. Let's start the game. Just play it. Just love the subject. Don't think that we are learning something hard. We should focus. Don't pressurize your mind. Just have a peaceful mind and just have calm peaceful set in your from your brain set. Just listen to the concept and try to apply the fundamental basics that you have learned so far. Okay, chalo, let me bring the first question in front of you. There is one question. What they did is they took an inductor and they have directly connected this inductor with the SCR, silicon controlled rectifier. Then what they did is they told that this set is connected with a DC supply. When the moment I have seen this, I understood that DC supply with the inductor means they are talking about transient phenomena. I clearly understood this. And then they told this inductance value is 0.14 Henry. Then they are calling it as this is called simply thyristor. And here we are going to keep exactly 140 voltage. Next, battery supply polarity is clearly given. Now the question is, if the latching current in the circuit shown is below 5 ampere, latching current in the circuit shown below is 5 ampere. They told that latching current for the circuit is 5 ampere. Now obtain the minimum width of the gate pulse. Obtain minimum width of the gate pulse. Obtain the minimum width of the gate pulse required to properly turn on the SCR. Required to properly turn on. Required to properly turn on the SCR, silicon controlled rectifier or thyristor. This is the given question. Now you can take 3 to 4 minutes I am giving because it is initial stage. Just explore your knowledge. How do I figure out this? See, basically you know the definition of latching current. Yesterday we saw. Then you know the meaning of this gate pulse width. Pulse width means, okay, you can think. Then you also know the transient effect. You know how to analyze the basic property of an inductor. Remember one more thing. Here resistor is not given. So now it's your responsibility to explore the knowledge, try to bring out the answer. Take your time, drop your answer. Do it fast. Just spend some time to explore, apply the basic knowledge. Don't think too much. Anyone got the answer? Wow, majority of you. Geeta 5, Sugumari same 5, Geeta same 5 microsecond. Okay, then Kanaka Savita 5 microsecond. Very good. Any other? Any other? Any other answers? So let me try to drop the answer here. See, basically, what are all the key that is given to us and how to explore in this let us see. First of all, in this given circuit, the value of resistor is not given. When resistor is not given, we can assume that value is 0. So we no need to talk about the time constant here. For this given circuit, we have only inductor. So when the moment time constant effect is not there, we can directly explore. Only inductor is there, thyristor is there, 140 voltage is given. Now I'm just asking you, yesterday we have been discussed about two type of current. One is latching current and another one is holding current. I hope you all have remember it. And we saw the basic difference. Basically, latching current will be dealing with the on state process. Holding current will be dealing with the turn off process. This is a turn on process of SCR. This is a holding current is dealing with the turn off process of SCR. Yes or no? And we also saw one more relation. Latching current is always higher than the value of holding current. This relation also we saw. Okay, sir, fine. So, in order to turn on the SCR, definitely we will be dealing with the latching current. First conclusion. So, whenever they are talking about in power electronic circuits, whenever they are giving this kind of a thyristor circuits, definitely they must talk about latching current. It doesn't matter whether they are talking about holding current or not, but they must talk about latching current. Now, if you observe our question, yes, latching current is given. What is the basic definition of latching current? It is the minimum amount of current that it should be required in order to, that is, in order to maintain the SCR above the on state. SCR வந்து on state க்கு மேல வரணும், on state ல இருக்கணும் அப்படின்னா this current is mandatory. அப்ப நம்ம latching current சர்க்யூட்ல கண்டினியூஸா மெயின்டைன் பண்ணாலே போதும். SCR என்ன இருக்கும்? So this is the minimum amount of current that is required in order to turn on the SCR. SCR turn ஆனதுக்கப்புறம் இதில் மெயின்டைன் பண்ற minimum current. So I can say this current is sufficient in order to maintain the on state. அவங்க என்ன கேட்டிருக்காங்க? So latching current 5 milliampere கொடுத்துட்டாங்க. Minimum width of the gate pulse. Minimum width means basically they are talking about time only. Yes or no? We are injecting the gate current. We are injecting the gate current, but they are asking how long you have to inject the gate pulse continuously with respect to time period. Suppose if I am injecting a current, a gate current, how long you will be continuously injecting this current? This width only they are asking. Basically, this gate current we won't apply continuously to the SCR in order to avoid the power loss. If we are continuously injecting the current, gate current to the SCR during the on state, there is a chances of facing thermal runaway. In order to reduce the temperature, thermal runaway, what will happen? You know, in SCR, if you observe, we are having three terminals. Yes, sir. So when the moment we are having three terminals, we will be injecting the current from anode to cathode. This is one current. And when we are trying to apply gate current also continuously, what will happen is inside there is one spot. In that region, see this anode current and gate current both will combine together. So what will happen is resultant, the net current through the SCR will be increasing continuously. It will increase the temperature. It may lead to damage the SCR or reduce the lifetime of the SCR. So in order to avoid this issue, usually instead of applying the current continuously, people started, they have stopped sending the current continuously. They started finding the minimum time duration that is required to send the gate current. Like if you are if you are injecting the gate current for a duration of 5 millisecond, 5 microsecond, whatever, SCR is turned on. Then what they will do is again they will leave a gap. Again they will inject the current for 5 microsecond. Again they will leave a gap such that Now what will happen? See, we are sending the current, again there will be no current, again we are sending the current. Now what will happen? Temperature will increase, again decrease, again increase, again decrease. So we are doing compensation here. So people understood that the effective way of turn on the SCR is gate through the gate pulse. Anyway, we need gate current, but we don't need to inject it continuously in order to reduce the effect of temperature losses or in order to improve the lifetime of the SCR. We have started injecting the gate pulses instead of sending the continuous current. That's why nowadays you can observe, see, this type of question are being repeated in many exams. I'm also observing recently, whatever the exam that I wrote, in many of the exam that I wrote, I observed that these questions are getting repeated. So because this is the reason, it's application. This is basic application of ACR. Fine, sir. Now the question is, what is the minimum pulse duration? Already they told that now latching current for 5 milliampere is continuously going. So how long we are injecting the gate current in order to maintain this on stage? அப்போ SCR ஆன் ஆகும்போது மினிமம் அதில் எவ்வளோ கரண்ட் ஃப்ளோ ஆகும் அப்படிங்கிறது நமக்கு தெரியும். கரண்ட் ஃப்ளோ த்ரூ தி சர்க்யூட் இஸ் 5 milliampere latching current. This is the minimum current that is required such that we can ensure that if 5 milliampere current is incirculating through the SCR, we can say, sir, SCR is turned on. How do you know? Because you know the definition of latching current. When you are observing the latching current through the SCR, you can say, sir, device is perfectly turned on. It's beautiful. Now, how do I figure out that time period? So let me tell you. When the moment you have only inductor, figure out the relation between voltage and current. When we are having only inductor, remember, keep this word in your mind. In case of inductor, because in this given circuit, how we are fixing this time period? It will be fixed by the inductor because inductor will not accept the instantaneous changes. You all know that. So from that we can figure out so how much time it is taking. Okay sir, in order to let this 5 milliampere current, what will happen is inductor will be slowly allowing the current to the maximum value. If latching current is 5 milliampere, it started initially when the moment you are started giving this triggering pulse. When the moment you have started see, let me tell you, suppose I have started injecting the gate current at 0 millisecond, microsecond, whatever. It is started now. What will happen is when you have started increasing the injecting the current through the gate, slowly SCR will start its on process, turn on process. So through the SCR, if you observe the current pattern, anode current with respect to time period, if you observe the SCR, what will happen is it will started allowing the current slowly from 0 to latching current. First it will go to latching current. So slowly with respect to time, current will be increasing. So when you are continuously injecting the gate current. So after certain time period, what will happen? So minimum time period. For example, now you people are telling that 5 microsecond answer is. So answer நீங்க அப்படி கண்டுபிடிச்சிருக்கீங்க இல்லையா? I'm not sure. Let us cross check. அப்ப கரெக்டா வந்து நீங்க 5 microsecond வந்து continuous gate pulse inject பண்ணி முடிக்கும் போதெல்லாம் the current through the anode will be reaching 5 milliampere. That's all. So after that, what will happen? SCR will turn on. Continue completely SCR will turn on. So they are asking in the time period வந்து examல கேட்டிருக்காங்க. Like in the questionல கேட்டிருக்காங்க. That's all. Now you might have understood why I am spending these many minutes here. Because in some cases, what people will do is in the examination, instead of giving inductor alone, they will be giving the inductor plus resistor. In that case, you will be traveling along with the complete transient effect. Because when resistor is fall in place, what will happen? Time constant will be observed. Inductor will take some time. So the inductor charging time is depending on the value of resistor also when resistor effect is given inside the network. It will become RL circuit. You know how to do analysis when we are having RL circuit in our hand. Fine, sir. We have understood everything. So finally, you are correct. This gate pulse current is now we have to make sure for how long we have to inject this current. So see, this current increment, why we are facing this current increment like this? Why current is not suddenly injected? Because transient effect. Inductor is there. Inductor will not allow the circuit to do that. You all know inductor will not accept the instantaneous changes in the current. Current through the inductor will not be accepted. Similarly, in case of capacitor, you cannot change the instantaneous, you cannot give instantaneous effect in the voltage value of the capacitor. You cannot give the instantaneous effect to the current offered by the inductor. இண்டக்டருக்கு வந்து கரண்டோட வேல்யூ டக்குன்னு நம்ம சேஞ்ச் பண்ண முடியாது. கெப்பாசிட்டர்ல வோல்டேஜ் வேல்யூ டக்குன்னு நம்ம சேஞ்ச் பண்ண முடியாது. நீங்க இமீடியட்டா அப்ப என்ன யோசிக்கணும்? அப்ப கெப்பாசிட்டரோட கரண்ட்டை நம்ம டக்குன்னு சேஞ்ச் பண்ணிக்கலாம். இண்டக்டரோட வோல்டேஜ் நம்ம டக்குன்னு சேஞ்ச் பண்ணிக்கலாம். பட் in capacitor voltage cannot be possible. In inductor current cannot be possible. You all know these things because this is basics of transient. We know that. So here we understood that clearly. We are talking about current only, no? But that current is already given. When the moment we are reaching this 5 milliampere, when the moment the inductor is allowing this 5 milliampere, that is the point where SCR will turn on. அப்ப yes, inductor வந்து எந்த டைம்ல அந்த current வந்து allow பண்ணும். This is the relation. எல்லாருக்கும் வந்து உங்களுக்கு டவுட் என்ன வரும்னா இந்த மாதிரி கொஸ்டின்ஸ் வரும்போது யூ பீப்புள் ஆர் திங்கிங் அபவுட் கேட் கரண்ட். கொஸ்டின்ல கேட் கரண்ட் தானே எவ்வளவு நேரம் இன்ஜெக்ட் ஆகுதுன்னு கேட்கறாங்க. அது எப்படி நம்ம சர்க்கியூட்ல இருக்க பேராமீட்டர் வச்சு அனலைஸ் பண்ண முடியும்? இதுக்கு நமக்கு கேட் கரண்டோட ப்ராப்பர்ட்டி தானே தெரியணும் அப்படின்ட்டு யூ பீப்புள் ஆர் திங்கிங். No, gate current is being injected constantly. Yes, of course, I am observing that. But why it is taking certain time period? Because it is due to the behavior of the elements that are connected in series with the SCR. Whether it is in series or parallel doesn't matter. So the time taken by the circuit to reach this latching current, it's only depends on the parameters or elements that are connected with the SCR. So here அதனால தான் வந்து இந்த கேட் கரண்ட் வந்து நம்ம இன்ஜெக்ட் பண்ணும்போது இந்த பல்ஸ் வித் அப்படிங்கிற டியூரேஷன் வருது. எஸ்சிஆர் டர்ன் ஆன் ஆகணும் அப்படின்னா லேச்சிங் கரண்ட் வந்து அதை ரீச் பண்ணணும். லேச்சிங் கரண்ட் அது உடனே ரீச் பண்ணுதா இல்ல கொஞ்சம் டைம் எடுத்துக்கிட்டு ரீச் பண்ணுதா? அது யாரை டிபெண்ட் பண்ணி இருக்கு அப்படின்னா எஸ்சிஆர் கூட கனெக்ட் ஆகிட்டு இருக்க அதர் எலிமெண்ட்ஸ். நம்ம சர்க்கியூட்ல இண்டக்டர் மட்டும்தான் இருக்கா. So it is very easy to observe now. Figure out the inductor current. How do I do that? We all know. Let me draw the solution for this. Now you might have understood. So when you are having only L circuit, inductor மட்டுமே இருந்தது அப்படின்னா what you must do is just directly write out the relation between voltage and the current for the inductor. Find out the time period. Finish. When we are having RL, inductor and resistor, ரெண்டு பேர் இருந்தாங்க அப்படின்னா what we have to do? In that case, let me drop here. I don't have space. So we know the current through the inductor can be written as, sorry, this is what I want. So let me derive from the basic. We know V is equal to L into DIL by dt. This is the current flow through the inductor. I need inductor current. So from this I can write DIL equal to V by L into dt. Am I right? I just kept inductor current one side. I have passed the remaining all to another side. Now I am taking indefinite integral on both sides. You know, indefinite integral means directly without limit we are doing the integration. In left hand side I am doing integration with respect to current. Right side we are going to do integration with respect to time period. So left hand side this indefinite integral and the differential will cancel such that you will be coming up with the inductor current. Right hand side if I will do indefinite integral with respect to time period, then it will give you the value of V by L into time period t. That's all. See there. Now what is the minimum amount of current that must flow through the inductor? Inductor வழியா போக வேண்டிய minimum current என்ன அப்படின்னா latching current. This is inductor current basically. This inductor current must be equal to the value of latching current such that SCR will turn on easily. ஏன்னா inductor SCR both are connected in series. If inductor starts allowing this latching current, this is latching current means minimum on stage current that it should be required through the SCR to turn on the SCR, right? That is required to turn on the SCR. So I can say this inductor current basically is equal to latching current. Yes sir, fine. Now let us inject this. அப்ப இந்த இடத்துல நம்ம என்ன பண்ணிக்கலாம் அப்படின்னா in place of the inductor current you can put 5 into 10 power minus 3 equal to the voltage drop. Next we will be focusing on the value of voltage drop divided by inductor value is already given 0.14 into time period t. At least tell me now what can be the expected answer for this question, because I have given all the clue. Now hereafter there is no difficulties in order to figure out the answer. Only time period is required. So what is the voltage that will be dropped across the inductor now? So that is very simple. We have only one person here, that is supply voltage. Automatically that voltage will be dropped across the inductor. So supply voltage is already clearly given, that because there is no any other voltage, given it is supply voltage that will come across to the inductor, that will be injected, right? So I can say simply that will going to be supply voltage only. So from this the value of time period t can be written as 0.14 divided by supply voltage Vs into 5 into 10 power minus 3. Now supply voltage is equal to 140. I can substitute here. Now it is time C. What I will do is you have to reduce this value in a proper way. What we got basically, I am writing here. T is equal to 0.14 upon 140 into 5 into 10 power minus 3. Am I right? This is the value that we are having now. Yes. Now, just to multiply the numerator by 100 such that it will become 40. Denominator also I am going to multiply it by 100 such that it will be like this. So, 5 into 10 power minus 3. How do we reduce this further? Very simple. See there. 14 will be cancelling directly. Now, here we have 1 0. Here we have 2 zeros. It can be written as 10 power 3 to overall. 10 power 3, if I will bring it to the numerator, it will become 10 power minus 3. So totally two 10 power minus 3 are there. 10 power minus 3, 10 power minus 3 can be written as 10 power minus 6. So 5 into 10 power minus 6. This can be written as 5 microsecond. So the time taken by the SCR to turn on is exactly 5 microsecond. It's a chilly question. I know it's very easy. Of course, that is also we know. But keep your attention in the examination hereafter. Whenever you are facing this kind of question, don't be bothered. What you people are thinking is, oh, it is really too difficult. We haven't seen this type of model anywhere. Why you have to see? You know the basic, right? What I have did here. This is the fundamental basics that you have learned at the very first beginning of circuit theory. You know this formula very well, right? So it is very important to get the deep understanding, not deep analysis. Sorry, deep analysis and understanding both same. Depth knowledge is not required, deep understanding only is required here. You should bring the relation between other subjects also, right? Fine, sir. Now you might have understood. Now just think about it. Sir, suppose in the same case, if a resistor is inserted in the circuit, what should I do? In that case, what you have to do is just write down the expression for current through the inductor in the same way that I did here. Here I wrote the inductor current because directly only inductor is given, resistor is not given. When resistor is having its presence in the given circuit, what you might have do? So write the general expression for RL circuit. I hope you all know that. Wait. See guys, in the same circuit, if resistor and inductor effect is given together, it is not only in series, it may be in any other configuration. Don't think that only inductor should be connected in series, we can write the expression. No, we saw in transient circuits, RL circuit can be in any way. This resist, you can keep 2 or 3 resistors in series parallel configuration and in any way. Okay, I can't give a surety that circuit will be like this. I'm just telling that when resistor also will be showing its presence, then write down the expression for current flow through the inductor IL of t. Okay, so how will you write? The formula is IL of t is equal to IL of infinity plus IL of 0 minus IL of infinity into e power minus t by tau. Here you know how to calculate the current flow through the inductor at initial stage. You know how to calculate the current flow through the inductor at the final stage. You know how to calculate the time constant tau. Now explore all these values, then substitute here. Then what should I do, sir? Then just to check if the inductor is directly connected in series with the SCR, then I can say current flow through the inductor will be equal to latching current only. So directly you can substitute this value. Latching current will be given in your examination, and the one and only unknown parameter finally is your time period. If you reduce this, you will get the expression. But remember one more thing. Here you can directly IL of t ஓட வேல்யூவை நீங்க என்னன்னு கண்டுபிடிக்கணும். இது எந்த இடத்துல present ஆயிருக்கு அப்படிங்கறத கண்டுபிடிக்கணும். That is very important. If it is in series with the SCR, then there will be no issues. Otherwise, in some cases, there might be some other clue will be given. Based on the clue, you can explore the circuit. Okay, but this is common. Mostly they will do these kind of things. Let's see if you find any new question, just figure out it by yourself. Okay, anyway, this is the logic that you must apply when the circuit will be given with the resistor also. Okay, fine, sir. Another question polama. So this is the given second question. Basically what they are asking is they are willing to turn off the SCR. Okay, they are willing to turn off the SCR. So what they are asking us is, in order to turn off the SCR, first they are giving one statement. So in order to turn off the SCR, the anode current, that is anode current means anode to cathode current, current that is flowing from anode to cathode, that is called anode current. Anode current must go. So you have to decrease the anode current or increase the anode current. என்ன பண்ணணும்னு கேக்குறாங்க first. In order to turn off the SCR, first statement they are talking about anode current. Anode current must be decrease or increase. இது ரெண்டுத்துல எதை பண்ணணும்னு கேக்குறாங்க. Second thing, இது first. இதுல நீங்க decrease பண்ணுமா increase பண்ணுமான்னு கண்டுபிடிக்கணும். And then second இதுல என்ன கேக்குறாங்க அப்படின்னா, whether this anode current must be below or above the latching current or holding current. இது வந்து below holding current இருக்கணுமா இல்ல above holding currentல இருக்கணுமா இல்ல below latching currentல இருக்கணுமா இல்ல above latching currentல இருக்கணுமா? That is the second question. Next, in order to turn off the SCR, they are talking about the voltage. The voltage across the SCR is equal to reverse voltage, that is reverse bias voltage or forward voltage, or it should be zero. SCR turn off பண்ணோம் அப்படின்னா அதுக்கு அக்ராஸா வந்து என்ன மாதிரி நெகட்டிவ் வோல்டேஜ் ட்ராப் ஆகணுமா பாசிட்டிவ் வோல்டேஜ் ட்ராப் ஆகணுமா இல்ல ஜீரோ வோல்டேஜ் ட்ராப் ஆகணுமா? So type your answer sequentially. Like when we are talking about anode current வந்து நம்ம SCR வந்து turn off பண்ணோம் அப்படின்னா first எழுதுங்க, decrease பண்ணுமா இல்லை increase பண்ணுமான்னு எழுதுங்க. And then second statement. So below or above ஆன்னு எழுதுங்க. Below or above means basically we are talking about holding or latching current. Below and then holding current or latching current. Above or holding current or latching current. Then reverse voltage, forward voltage, zero voltage. இதில் யார் வரணும்? So basically you have to drop the answer. They have given four options like this, like decrease, increase, below or above, latching current or holding current. Here reverse voltage, forward voltage, zero voltage. Like that they have framed four options. I don't think that is required because guessing something, நீங்க அதை பார்த்தீங்கன்னா you might be guessing the answer. That is not required here. Do it yourself. SCR turn off பண்ணோம்னா இந்த சீக்வன்ஸ் எப்படி எழுதுறீங்க? ஆனோடு கரண்ட் வந்து என்ன பண்ணணும், அதை வந்து latching current கூட கம்பேர் பண்ணுமா இல்ல holding current கூட கம்பேர் பண்ணுமா? அப்படி கம்பேர் பண்ணும்போது அது below-ல கொண்டு போகணுமா இல்ல above-ல கொண்டு போகணுமா? What would be your correct answer? Take 2 minutes maximum. Just type your answer in the comment section. Do it fast. Do it fast. Anybody? I hope you all have understood the question, right? I don't think that you people are having doubt with the question. Do let me know if you have any issues. No problem. I'm here to help you. But keep smile in your face. சீரியஸாக தயவுசெய்து எதையும் பண்ணாதீங்க. பிகாஸ் நீங்கள் அந்த மாதிரி பண்ணி தான் பிரைன் இஸ் திங்கிங் ஓ வி ஆர் டூயிங் சம்திங் ஹார்ட். எழுந்திருக்கும் போதே ஃபீல் பண்ணும், அரே வி ஹாவ் டு அட்டெண்ட் தி கிளாஸ். It will happen when you are stretching your brain. Just love the subject. Every day say, no, we are going to learn something beautiful. எங்கேயாச்சும் டூருக்கு போனோம் இல்லை படத்துக்கு போனால் காலைல 4 மணிக்கு எழுந்திரிக்க சொன்னால் எழுந்திரிக்கிறோம்ல, you should create that kind of effect in your brain when you are studying. Anode current decrease below the holding current, reverse voltage. Very good, Sukumari. Manivandan, below the anode current, below the latch. Sorry, below anode current. Okay, below means decrease. Okay, decrease the anode current. and below the latching current. Okay, voltage, what about the voltage? Manivanna, Geeta, decrease below reverse voltage. Good. Suhaina, anode current decrease, latching current, below the latching current, reverse voltage. Okay. Pulmonar Sahasing. Anode current is decreased less than the holding current, negative VR. Okay. Below the holding current, Gauri Mukti. Reverse the voltage, anode current decrease. Okay. Okay, reverse voltage. Okay, yeah, negative voltage means basically this reverse voltage. Fine, good. What other people are doing? I'm observing there are so many people. Just drop your answer. It's not a big question because already you might know the basics. And we saw yesterday also, I I just given a recapture for all these questions. Basics. Okay, I'm just asking you one question. Let us start the process. Listen. Let me take a diode. In the question number, let us go back. Let me empty this slide first. See, first of all, let us take only one diode. Okay. So basically, diode will be having two terminal. One is called anode terminal, another one is called cathode terminal. Yes or no? Yes. So if you see its internal property, it is having two junctions. One is P, another one is N junction. This is called PN junction. Exactly, that is true. Now the question is, I'm simply asking you, before talking about the ACR, I'm just asking you, if you want to turn on this diode, basically what will you do? So let us say, initially the anode current is carrying a certain amount of current. They told that anode current means they are talking about anode to cathode current only. Remember this, nothing is there. Anode current means basically that will be equal to anode to cathode current only. Some people will be using K also, don't get confused with that. So initially, suppose if your device is carrying, they are telling that some 10 milliampere current. Take very less value. I'm not going to deal with this with respect to time period, maybe in millisecond or microsecond, whatever it is. Now suddenly they are asking you just to turn on the diode. What will you do? This current is going, okay? Or you can take a fan. இப்போ ஒரு fan வந்து வீட்ல வந்து ரன் ஆயிட்டு இருக்குன்னு வச்சுக்கோங்களேன். Okay, there is one fan is running. Assume it is fan. I know it is not a fan. It's not looking like. So fan is running at 1000 RPM. Just compare it with the practical explanations. Sorry, practical circuits. 1000 RPM. இப்போ போயிட்டு ஃபேனை switch off பண்ணுங்கன்ற என்ன நடக்கும்? You just tell me. இப்போ ஃபேன்ல வந்து என்ன ஆயிட்டுன்னா this is called mechanical speed. ஆனா இதுக்குள்ள என்ன போயிட்டு இருக்கு அப்படின்னா நம்ம பண்ணிருப்போம். இதுல என்ன கனெக்ட் பண்ணிருப்பீங்க? ஒயர் கனெக்ட் பண்ணிருப்பீங்க. இப்போ இது 1000 RPM ல ரன் ஆயிட்டு இருக்கு அப்படின்னா definitely it will be taking some 2.5 ampere current. Let us take. Enough. ஸோ அப்போ இந்த மாதிரி டைம்ல என்ன நடக்கும்? யூ ஜஸ்ட் டெல் மீ. நான் உங்களை ஸ்விட்ச் ஆஃப் தி ஃபேன் அப்படின்னு நான் சொல்றேன். என்ன பண்ணுவீங்க? யூ வில் பி கோயிங் டு ஸ்விட்ச் ஆஃப் தி ஃபேன். ஸ்விட்ச் ஆஃப் பண்ணீங்கன்னா அப்போ என்ன நடக்கும் இமிடியேட்லி? திஸ் இஸ் கால்டு டிரான்சியன்ட் எஃபெக்ட். திஸ் இஸ் டிரான்சியன்ட் எஃபெக்ட். எக்ஸார் நோ, நீங்க போயிட்டு அப்படியே ஃபேன் ஆஃப் பண்ண உடனே அந்த இன்ஸ்டன்ட்லி ஃபேன் அப்படியே நின்றுமோ டக்குன்னு? நோ. வாட் வில் ஹேப்பன்? இட்ஸ் அ it is having certain inertia. The speed will be gradually reducing. Yes or no? Yes, because inside the fan we are having coil. Coil means inductor plus resistor combination. This is basically called coil. We all know this is called coil. So this coil will be having certain moment of inertia. It will take some time to reduce the current to zero. At the same time, it will take some time to reduce the speed to zero. This is called mechanical transient. This is called electrical transient. Same thing you can observe here. When the moment you are trying to turn off the diode or SCR, whatever I told you, there is one junction is called depletion junction. There you can observe the properties of capacitors. I am giving you a small task here. When diode in forward bias, what type of capacitor we are observing? Identify the names of the capacitors. What is the names for the capacitor when the diode will be in forward bias? What type of charging will be happen and how we are naming the capacitors? When diode in reverse bias, It is very important. There are so many questions related to this. So when diode in reverse bias, what type of capacitor will be present and how we are naming the circuit? See, it is very important to know the names of the capacitors. Okay, other things are not important here. Just try to identify the names of the capacitor. Anyway, one thing will be for sure, that across the deflection layer we will be observing the properties of the capacitor. So capacitor will be having certain moment of inertia. That moment of inertia will not allow the capacitor current to get zero immediately when the moment you are trying to turn off. So we are dealing with the turn off process. Just now see, they are dealing with the turn off process. So in order to turn off the SCR, when the moment I am trying to make this anode current is due. So what you have to do now, you have understand that if you want to turn off the device, we must decrease the current. Yes or no? Then only circuit will turn off like our fan. If you want to turn off the fan, you must decrease the current. You must decrease the speed to zero. Same way, if you want to turn off any devices, we must decrease the current flow through the device. Yes, sir. So anode current has to be decreased, but it will not go to zero immediately. It will take certain time period. Slowly it will going to be zero. This is the way it will get zero, anode current. Why? Because this is the effect of capacitor. You might also observe that after that what will happen? A reverse current will flow. It will go to maximum point. Yesterday we saw. This is called the maximum reverse peak current. So there we are observing that time also, time taken by the capacitor to go. It will reversing the time taken by the capacitor to reach the maximum peak current. After that, how much time it is taking to decrease 25% of this maximum value. So I kept 1 by 4 times of IRM. So we are dealing with that is called a TB. This process is different. Then we saw faster recovery, softer recovery. So many things we have recaptured yesterday. So one thing what you have to understand here is this diode will not take immediately, it will not make the current will be zero. This current will be slowly decreasing, decreasing, decreasing. Switch will be turn off when the diode will turn on, turn off, turn off. நான் என்ன சொன்னேன், on time process பேசிட்டு இருக்கும்போது you must be talking about latching current. When you are discussing about the turn off process, you must be talk about holding current. Yes or no? Basically we are dealing with the turn off process. So we are dealing with the turn off process. If you want to turn off, you must reduce the current below to the holding level. இந்த ஹோல்டிங் கரண்ட், இந்த கரண்ட் கீழே போனா அந்த எஸ்ஆர் டர்ன் ஆஃப் ஆயிடும்பா அப்படின்னு சொல்றாங்க இல்லையா, அந்த கரண்ட் கீழே நீங்க குறைக்கணும். So that current value might be defined somewhere here in milliampere, some 2 ampere, 3 milliampere, that is less than latching current. You all know that. So latching current is always greater than holding current. So holding current definitely less than latching current. Some minimum milliampere current is required to keep the device in on state. If you go below that level, automatically device will be turned off. So நீங்க அந்த கரண்ட்டுக்கு கீழே நீங்க கொண்டு போயிட்டீங்க அப்படின்னா automatically what will happen? Device will be turned off. Yes or no? So the first conclusion what you have understood is it may be a diode or SCR here below holding current, below holding current, such that device will be turned off. Now they are coming back to the next point. Sir, how to turn off? Is there any possibility இதே device வந்து நம்ம voltage வச்சு turn off பண்ண முடியுமா அப்படின்னு கேட்டாங்க அப்படின்னா, let us coming to that point also. So when the moment we are talking about the voltage, what will happen to the SCR? Voltage in the sense we have to reverse the polarity, right? Yes, sir. Basically we have to reverse the polarity. How do we reverse? See, let us see. We have seen in even in diode also, we saw the region is called reverse bias region. அப்படின்னா மீனிங் என்னங்க? reverse bias region மீனிங் என்ன? Basically when diode in forward bias, current will be flowing from anode to cathode, and across the anode we will be injecting positive voltage, across the cathode we will be injecting negative voltage. This is when diode will be in forward bias or on state. It may be SCR also, same process. Don't think too much. In SCR one more person will come, that is called gate pulse. Anyway in your question they haven't talked about gate, so I'm directly talking about, I'm just interlinking SCR with the diode. Nothing will be differ from here. You can observe the same property for the SCR also. Okay, fine sir. Now what I'm going to do is I'm reversing the polarity across the diode. What will happen? It may be SCR also. If I'm reversing the polarity for the SCR, you can inject one more terminal such that it will produce the properties of SCR. That's all, it's over. This is SCR now. When you are reversing the polarity, what will happen? When you are reversing the polarity, automatically, see, I am injecting positive voltage here, negative voltage here. Let me explore elaborately. If you are taking SCR deeply, you might have observed there are 3 junctions inside the SCR. 1, 2, 3. Yes sir, there are 3 junctions. Guys, I am spending much time because you have to understand the analysis. If you are facing any other questions from this area, you will be able to do all this analysis in a proper way. So understand these things very properly. Nothing is there to understand. Just see how I am doing the analysis. And I am not teaching any new concept here. I am just interlinking all the concepts which we have learned so far. Fine, sir. See, there are three junctions. When the moment I am injecting negative voltage here, positive voltage here, let us see what will happen. So let us see PN, PN. We are taking this one only. Now take the junction 1. What will happen here? If you observe the junction 1, one side we have positive, another side we have negative. That is positive charge and a negative charge. Now externally we are injecting. This side I am injecting positive voltage, this side I am injecting negative voltage. See there, this negative supply voltage will be attracting this positive charges. This positive supply voltage will be attracting this negative charges. In resultant, what will happen? These charges will started traveling towards the supply. This positive charges started traveling towards the supply. Then who will taking care of this layer? No one. Everyone started going out. So this will turn off completely it will be turn off. There will be no any further flow. Whoever flowing initially, they have started traveling in the opposite direction now due to the attractive reversal of the polarity of the supply. So this is the beautiful phenomena that we are observing in the inside the SAR. Observe the second one. So what we understood is junction 1 is going to the reverse bias, is entering into reverse bias. Similarly, if you observe the junction 2, what will happen? It will be entering into forward bias, undoubtedly. What about junction 3? It will be entering into reverse bias. You all know reverse bias means open circuit, forward bias means short circuit. But the problem is, if any one diode is open circuit internally, if any one junction is open circuited, then current will not flow inside the layer. Current will not flow means device will be turned off. That is the meaning, yes or no? Current will not flow means switch, that is the circuit will be turned off. So it could be possible when the moment you are reversing the polarity, then only this device will turn off. With the help of forward voltage, you can't do, because in the SCR, they have not talked about the gate current. Did they reduce the value of gate current? No. By default, when they are not talking about the gate current in your circuit, it means they are continuously applying the gate current. By default, when there will be no any information about the gate pulse in your examination in SCR questions, SCR type question, they are continuously applying the gate current. Otherwise, they will be talk about it. இந்த மாதிரி கொஸ்டின் வரும்போது கேட் கரண்ட் பத்தி பேசுறேன்னா கண்டினியூஸா ட்ரிகர் பண்ணிட்டு இருக்காங்கன்னு அர்த்தம். But what is the use of it? When we are reversing the polarity across the SCR or when we are reducing the anode current, automatically this device will turn off. I hope you all understand this. So this is how we are switching off the SCR, by doing these two processes. So finally, what is the conclusion here? So the first conclusion is, by decreasing the anode current below the holding current, we can turn off. And second thing is, by reversing the voltage across the SCR, we can turn off the device. You got it now? That's all. So I hope you all have understood this process. Okay, sir. Fine. Now I am raising one more question. Okay, it is your responsibility to drop the answer. Not here, you can discuss with your friends in the group. இப்போ நான் என்ன பண்றேன் அப்படின்னா, ஆனோட கரண்ட்டை நான் அப்ளை பண்ணிட்டு தான் இருக்கேன் அன்டவுட்ஃபுல்லி. பாசிட்டிவ் வோல்டேஜ் இங்கே அப்ளை பண்ணிட்டேன், நெகட்டிவ் வோல்டேஜ் இங்கே அப்ளை பண்ணிட்டேன். பட் ஐ எம் ரிமூவிங் தி கேட் கரண்ட். வாட் வில் ஹேப்பன்? ஐ ஜஸ்ட் வாண்டட் டு நோ திஸ். ஐ ஜஸ்ட் மேட் தி வேல்யூ ஆஃப் கேட் கரண்ட் இஸ் 0. கண்டினியூஸ்லி நான் சுத்தமாக எடுத்துட்டேன், கேட்ன்ற டெர்மினலே ரிமூவ் பண்ணிட்டேன். வாட் வில் ஹேப்பன்? எஸ்சிஆர்ல என்ன நடக்கும்? திஸ் இஸ் வாட் ஐ வாண்டட் டு நோ. Just spend some time to understand the subject. Don't ask your friends what will happen. Nobody will tell you in the examination. Ask yourself what will happen. Go to the deep analysis. Open the junctions. You know how to expand it. Go to the junction wise. When we are removing the gate current, what will happen here? Whether this device will turn off or not, or it will continuously run in on state. Just do the analysis. You know why we are keeping this gate current. Now you have to know, if I will remove the gate current, what will happen there. Okay, that's all. Take the next question. In the question actually என்ன சொல்லிருக்காங்க அப்படின்னா, basically ஒரு 100 ampere SCR எடுத்துக்கிட்டாங்க and one more 200 ampere SCR எடுத்துக்கிட்டாங்க. Basically what is this symbol indicate here? This 100 ampere SCR rating, 100 ampere அப்படிங்கிறது you can pass maximum 100 ampere current through the SCR. So second 200 ampere means that is nameplate DTM. Maximum you can pass 200 ampere through the second SCR. These two SCR are going to be connected in parallel. Connect பண்ணதுக்கு அப்புறம் இந்த SCR வந்து ஆன் பண்ணதுக்கு அப்புறம் நீங்க அப்சர்வ் பண்ணி பார்த்தீங்கன்னா the voltage drop across the SCR வந்து எவ்வளவு வந்திருக்கு அப்படின்னா 2 voltage on state voltage drop across the SCR. Similarly, that is SCR1 க்கு. This is SCR1. This is SCR2. SCR2 ல பாத்தீங்கன்னா constant voltage வந்து 1.5. Just observe only this value. 1.5 voltage. இப்போ question என்ன கேக்குறாங்க அப்படின்னா ஒரு ரெசிஸ்டரை வந்து சீரியஸ்ல கனெக்ட் பண்றாங்க. both SCR. ரெண்டு SCRலுமே என்ன பண்றாங்க அப்படின்னா let me read the question. Calculate the series resistance that should be connected with each SCR. அப்படின்னா மீனிங் என்ன? இந்த parallel circuitல ஒவ்வொரு SCRக்கு across கிடையாது, in series with each SCR we are connecting one resistor, same value of resistor in both SCR connect பண்றாங்க. Now you are requested to identify this resistor, series resistor which is connected in series with both SCR. ரெண்டு SCRலுமே resistor connect பண்றாங்க. அந்த ரெண்டு SCR same value வச்சிட்டு இருக்கு. அந்த value வந்து என்னவா இருக்கும்? When the total current shared by these two SCR will become 250 ampere. Individual rating கொடுத்திருக்காங்க. இப்போ இது வந்து total rating. ரெண்டு SCR வழியாவும் போற total current வந்து நம்ம KCL போட்டு add பண்ணோம் அப்படின்னா it is consuming total overall current consumed by these two parallel combination will become 250 ampere. இது 250 ampere வரும்போது what can be the expected value of this resistor? Take 2 to 3 minutes because you people are in initial stage. I am giving one more minute also. You can take 4 minutes also. Try to drop the answer. Do it fast. கொஞ்சம் ஆக்டிவா இருங்க. ஜஸ்ட் லவ் பண்ணி என்ஜாய் பண்ணி படிங்க. ஓ we have studied about SCR பட் இந்த மாதிரி நம்ம கொஸ்டினை பார்த்தது இல்லையே. Create some curiosity in your brain. அதை பிலீவ் பண்ண வைங்க. We are not giving something doing very big. No. We are learning something to do far better than நம்மளோட எபிலிட்டி வந்து இன்க்ரீஸ் பண்ணுறதுக்காக we are doing something. So just love the questions, create some curiosity while observing something new in the subjects, such that your mindset will change slowly. Keep smile first. Do the solve the question. Bring the answer. Anyone? Answer please. Anyone got the answer? Guys, one small correction here. Sorry for that. Listen, kindly forgive me. This current rating is 300 ampere. I have updated the data of some other question near to this. Forgive me. Take the overall current is 300, not 250. Just change the total current consumed by these two people. The overall value is actually 300 ampere. That is not 250. Make it 300. You can continue further. Anyone? Answer please. I hope you all are trying. Just இந்த மாதிரி டேட்டா ஒரு சர்க்கியூட்டோட விஷய டேட்டாவை வந்து அப்படியே ரிட்டர்னில் எழுதியிருக்காங்க அப்படின்னா ட்ரை டு ட்ரா தி சர்க்கியூட் ஃபர்ஸ்ட். வரைஞ்சிட்டு ட்ரை பண்ணீங்க அப்படின்னா ஸ்டார்டிங் ஸ்டேஜில் போக போக அது உங்களுக்கு வந்துடும். ப்ராக்டிஸ் பண்ணோம்னா ஆட்டோமேட்டிக்காக மைண்டே வந்து டயக்ராம் வரைய ஆரம்பிச்சிடும். But earlier stage, when you are at the beginning stage, it is very important to draw the circuit such that you will get the complete idea. டைரக்டா மைண்டால கிராக் பண்ண முடியாத ஒரு சில விஷயங்களை வந்து நீங்க டயக்ராம்ல வரைஞ்சு பார்க்கும்போது it will be helpful for you. But நீங்க mathematics calculations எல்லாம் போடும்போது you don't need to write it on the sheet. Starting itself you can try to do with the help of your brain, because that is not the new thing for us. We did in our childhood. Now it is time to again recollect all those memories the way that you have done. Now it is time to do in the same way, a little beyond that. Total current is 300 ampere. There are two SCR, both are connected in parallel. ரெண்டு எஸ்ஏஆருக்கும் சீரியஸில் ரெசிஸ்டர் கனெக்ட் பண்ண போகிறோம். அதுக்கப்புறம் அது வழியாக போகிற டோட்டல் கரண்ட் தெரியும். இண்டிவிஜுவலாக அவங்க எவ்வளோ கரண்ட் எடுத்துக்கிறாங்க அப்படின்றதையும் ஆல்ரெடி கொடுத்துட்டாங்க. The maximum current consumed by them is 200 ampere and 100 ampere. Everything is given in the question. I don't think that you no need to take this much time. You can easily explore it. 5. Very good. Any other answer? First person got the answer. So I need to give 1 or 2 more minutes. Nice. But don't go beyond 3 to 4 minutes. Try to restrict. Slowly you can already stick to 1 or 2 minutes finally. Do it fast. பொறுமையாக பண்ணிட்டு இருக்காதீங்க, உட்காந்து யோசிக்காதீங்க ரொம்ப நேரம். ரொம்ப கான்ஷியஸாக இருக்கணும் while solving the problem. ஒரு டைமுக்கு அப்புறம் your mind will be habituated. ஓகே, இதை பார்த்தா இப்படி தான் பண்ணணும், ஃபாஸ்ட்டாக அந்த மாதிரி வந்துடும். But need some practice. Any other answer? One person got 5 ohm. Is it 5 ohm or milli? I don't have any answer for this question. I have to solve. Any other? Chalo, let me try to bring the answer. Listen. See, first I'm drawing the circuit. What they told is they are connecting one resistor in series with both SCR. I'm doing the same way that they told. Initially they kept only SCR. After that they have inserted a series resistance with both SCR. And they also told that these SCRs will be connected in parallel. 5 milliohm. Okay, ma'am. Done. See, this both will be carrying same value of R. They only told R series. I'm just writing R. This is SCR1. Let us take. This is SCR2. And let us consider this case, this circuit with the supply voltage. Supply voltage data is not given, but what they told is maximum current consumed. See, total load shared by them, that contributed value is given 300 ampere. Okay, fine. And the next thing is, you also know that out of this 300 ampere, total current, so maximum current that can flow through the SCR1 is clearly given, that is 100 ampere. It is direct question. Similarly, current flow maximum rating of the SCR2 also given. The current flow through this resistor is 200 ampere. That is also given. Yes, sir, it is fine. It is exactly given already. Next, since these two people are connected in parallel, yes or no? Yes, sir, they are connected in parallel. So I can say if I will measure the voltage drop between the terminal A and B, if I will measure the voltage across this first circuit, or sorry, this is second circuit, or if I will measure the voltage across this circuit, both will give you the same voltage or not. Potential difference between these two terminals can be measured in two ways, either by observing the voltage across this or by observing the voltage across the this area. Through this two way you can observe the potential difference. So let us keep our attention with the first one, first SCR. See, current injected through the first SCR is 100 ampere. Out of 300 ampere, they told that 100 ampere can flow through the first circuit and 200 ampere can flow through the second circuit. Tell me what is the voltage drop across this resistor? Current entering point here it is plus, leaving point is minus, and the voltage drop across this resistor will become 100 into R. Then what is the voltage drop across the SCR during the forward bias? Is there any voltage drop? Yes, sir. How will you find out that? It is already given. See the on-state voltage drop across the SCR is 2 voltage. How will I mark the polarity in forward bias? You all know when SCR will be turned on, it is similar to your diode. You may have the gate, but see that anode terminal will be positive, cathode terminal will be negative when it is in forward bias. So you can simply replace it by positive plate and a negative plate, and the voltage rating also given, that is 2 voltage. So I can keep that 2 voltage during the forward bias. Same if you observe the second thyristor, for that one also voltage rating is given as 1.5. So what I can do is I can redraw the circuit in this way. Just observe here. So first, there is one resistor and I am replacing SCR by its equivalent on-state voltage drop. Similarly here, just for problem solving purpose, I am doing this. I know gate current is there. We cannot draw like this directly. It is possible for diode, but for SCR, gate current should be considered. I know that, but I'm just solving, I'm writing these things on the paper only. Oh, nothing will be wrong. On-state voltage for the second SCR also given, that is 1.5. Yes, sir. So current entering through the first circuit already clearly mentioned, current entering point plus leaving point is minus for the SCR, sorry, for the resistor, because a resistor is a passive element. Resistor, inductor, capacitor all are passive element. For them current entering point should be plus, leaving point should be minus. Okay, sir. So resistor value is R, then the voltage drop can be written as 100 times of R. According to Ohm's law, V is equal to I into R. So the value of current flow through the resistor is 100, but the value of the resistance supported by the resistor is not known. So I'm considering it as R only. Then the polarity already we know, based on the properties of the SCR, we figure out already how that polarity will be fixed here. Voltage is 2. Similarly, current flow through the second circuit, it is clearly given that this value will be 200 ampere. And the value of the resistor is, sorry, what is the voltage drop across the resistor? 200 times of R. As usual, current entering point plus leaving point is minus. Now, for the battery, already polarity is given and voltage also given 1.5. Now, tell me, across these two terminal, what can be the total voltage? So, let me measure this voltage with the help of first SCR circuit. Then I will do the same thing with the help of second SCR. If I am going with the first one this way, how will you write? The total potential drop between A to B, VAB can be written as, can I write like this? Voltage drop across the first SCR, 100, sorry, for resistor 100 times of R plus 2. If you observe, see there, positive plate of the resistor, positive terminal of the resistor, positive plate of the battery, both are aiding each other. They are in the same direction. See there, current இங்க first resistorல enter ஆகும்போது first positive இருக்கு. அதே மாதிரி batteryல current enter ஆகும்போது positive தான் இருக்கு. So they are opposing each other. Sorry, they are aiding each other, not opposing. They are aiding each other. Aiding means we can do the addition. அப்போ அவங்க ரெண்டு பேரும் ஆட் பண்ணீங்கன்னா total voltage வந்துடும். In the same way, if you write the expression for this VAB in the alternative way means second way. The voltage drop across the second SCR. Second SCR கூட இருக்க resistor plus voltage drop will be 1.5. Anyway, you can measure this voltage in two ways. Now you can equate both RHS. If I will equate VAB both are equal. So I'm equating both RHS, right? So I can write like this. First case, 100 times of R plus 2 will be equal to 200 times of R plus 1.5. Any mistake in this? Just tell me now. This is the second model. Already இதே மாடல்ல கேட்ல ஒரு question கேட்டிருந்தாங்க. This is one more exam. I don't remember that name. இப்போ இதை reduce பண்ணுங்க. That's all. If I'll bring this 100 times of R to the right side, 200 minus 100 will give you 100 times of R once again. If I will pass this 1.5 to the left hand side, 2 minus 1.5 will give you 0.5 only. So the value of resistor R will become 0.5 divided by 100. What I can do? Multiply and divide your denominator and numerator by 10 such that numerator will become 5, denominator will become 1000 or 10 power 3 plus 3. If you are passing it to the numerator, it will become minus 3. So I can write 5 into 10 power minus 3 ampere, or you can say it is 5 milliampere. So finally, sorry guys, it is not ampere, it is ohm, 5 milli ohm. So what is the correct answer? So she got correct answer only. Good. So the correct answer is 5 milli ohm. This is the value of R. Okay. So apply your basic knowledge. I am just asking you now. நீங்க என்ன டெப்தா இங்க அனலைஸ் பண்ணீங்க? இப்ப எதுவுமே கிடையாது. ஆல்ரெடி என்ன சொல்லியிருந்தாங்க, எஸ்ஏஆர் பத்தி உங்களுக்கு தெரியும். அதுல ஆன்செட் வோல்டேஜ் கொடுத்துட்டாங்க. அதோட பேசிக் polarity, நம்ம ஆனோட் டு கேத்தோட்னா எப்படி polarity போடணும் நமக்கு ஆல்ரெடி தெரியும். எவ்ரிதிங் இஸ் கிவன். மேக்ஸிமம் கரண்ட் இப்போ எவ்வளவு ஃப்ளோ ஆக போகுதுன்னு சொல்லிட்டாங்க. ஆல்ரெடி அதுல எவ்வளவு கரண்ட் ஃப்ளோ ஆக முடியும் அப்படிங்கிறதையும் கொடுத்துட்டாங்க. இண்டிவிஜுவலா வந்து எஸ்ஏஆர்ல ஆன்ஸ்டேட் வோல்டேஜ் ட்ராப் எவ்ரிதிங் இஸ் given. The one and only unknown is R. You should apply the logic, basic logic. This is one way of solving this question. Some of you, what you can do is you can also apply current division rule if you are having common sense, right? So you should apply your common sense to bring the current division rule. Sir, total current is 300 ampere. Yes or no? Now you also you can find out, instead of நான் என்ன பண்ணேன்னா voltage drop வச்சு calculate பண்ணேன். நீங்க என்ன பண்ணிடலாம் அப்படின்னா, see, for this SCR, you know the on state voltage drop, it is 2 voltage first SCR க்கு. அதே மாதிரி on state voltage drop 2 voltage வேணும். அது வழியா போற current எவ்வளோ? 100 ampere. Can you find out the on state resistor or not? Yes sir. How will you do? R is equal to voltage offered by the SCR divided by resistance of current flow through this. According to Ohm's law, R equal to V by I. So in this way, you can find out 0.02 ohm for the first resistor. That is on state resistance offered by the first SCR. Now on state offered by the second SCR. That is 1.5 voltage divided by current flow through, that is 200 ampere. So it will be 0.075, right? So you can write down, it will be 0.075. Finish. That's not a big deal to identify. Okay sir, இப்போ ரெண்டு ரெசிஸ்டரையும் கால்குலேட் பண்ணியாச்சு. எப்படி சார் கரண்ட் டிவிஷன் ரூல் அப்ளை பண்றது? சி, ஃபர்ஸ்ட் எஸ்ஆர் கூட ஒரு ரெசிஸ்டர் கனெக்ட் பண்றாங்களா? இதோட ஆன் ஸ்டேட் டைனமிக் ரெசிஸ்டர் நமக்கு தெரியும். அதோட வேல்யூவை நீங்க இங்க சப்ஸ்டிட்யூட் பண்ணிக்கலாம். அதே மாதிரி செகண்ட் எஸ்சிஆர், ஆரோட வேல்யூ தெரியாது, பட் செகண்ட் எஸ்சிஆர்ல ஆன் ஸ்டேட்ல ரெசிஸ்டரோட வேல்யூ தெரியும். இன்ஸ்டெட் ஆஃப் கீப்பிங் வோல்டேஜ் ஐ எம் கீப்பிங் ரெசிஸ்டர், ஐ எம் ஜஸ்ட் கன்வெர்ட்டிங் இட். தட்ஸ் ஆல். டோன்ட் திங்க் டூ மச். So here this resistor value we know 0.02 ohm, second one is 0.075. Now this R value is not known, but current flow through the SCR is known. This is 100 ampere. Second one is carrying 200 ampere. Injected current is 300 ampere. Everything is known to us. Now basically how will you apply the current division rule? Sir, it is very easy. How? Suppose if you want to, இப்போ இந்த வழியா போற current உங்களுக்கு தெரியணும், overall current தெரியும் அப்படின்னா, current flow through the resistor is 100 ampere will be equal to overall current offered by the circuit is 300 ampere into, in the numerator, opposite resistor, opposite branch resistor, R plus 0.015 divided by total resistor, R plus R, it will be 2 times of R, plus add these two, you will get 0.035, I think. Sorry, it should be 75. So 0.095. It will be 0.095. See that the one and only unknown is R. In this way also you can reduce, you will come up with the same answer only. See, it is depends on your ability. நான் தான் சொல்லிட்டேன்ல, ஒரு ப்ராப்ளம் சால்வ் பண்றதுக்கு there are so many ways. நீங்க வந்து ஃபிக்ஸடா இதுதான் ஃபாலோ பண்ணணும் அப்படின்லாம் கிடையாது. First time I got this idea. And I know that it can be solved in this way also, but it is little bit indirect way, because directly if I know the voltage drop in one step I can drop the answer. This is also direct only, but இதை கம்பேர் பண்ணும்போது நம்ம ஃபாஸ்ட்டாக போடலாம், ஈவன் நம்ம மைண்ட்லேயே போடலாம். இதெல்லாம் current division நீங்க இந்த ரெசிஸ்டர்லாம் ப்ராப்பரா ஆட் பண்ணணும், then I have to pass it to the right side. It will take some 2 or 3 steps extra when I'm comparing it with the first one. So it is your common sense. How should I solve this question? Okay, it will come by practice, nothing to be bothered here. Okay, chalo, let us go ahead with the next question. 1 minute. Yeah, let me drop the next question here. Just be 1 minute. Yes, so let me bring. So there is one SCR. Once again, same type of question. Let us see how you people are answering for this question. We are going to have the resistor plus inductor is placed here, then and here. Yes, this is the exact one that I was looking for. I think this is previous year question only, maybe gate or bark, somewhere I have seen this. And here we are going to inject 200 voltage. Okay, let me drop the data. So given it is here, we are injecting 200 voltage, and this is the given ACR, and this resistor, 1 minute. This resistor R value is not known. This is 20 ohm, and here the value of the inductor is 1 Henry. It is given. Now the question is, the thyristor in the figure is carrying the latching current also given 100 milliampere. Latching current equal to 100 milliampere, and it is fired by a pulse length of 50 microsecond. They told that the given circuit, the thyristor in the figure has a latching current of 50 milliampere, and it is fired by a pulse width. Pulse width அப்படின்னா இந்த சர்க்கியூட் வழியா கேட் கரண்ட், அந்த கேட் பல்ஸ் வந்து நம்ம இன்ஜெக்ட் பண்றோம் இல்லையா, கேட் கரண்ட், இதோட பல்ஸ் வித்தையும் கொடுத்துட்டாங்க. யூனோ இதுக்கு முன்னாடி கொஞ்ச நேரத்துக்கு முன்னாடி தான் இது நம்ம டீட்டெயில்டா அனலைஸ் பண்ணோம். இந்த பல்ஸ் வித்த டைம் வந்து எவ்வளவு கொடுத்துருக்காங்க அப்படின்னா, இதெல்லாம் அவங்க வரையில, உங்களுக்கு புரியணுன்றதுக்காக நான் தான் வரைஞ்சிட்டு இருக்கேன். பிகாஸ் ஆல்ரெடி வி சா தட் நீங்க ஃபியூச்சர் அனலைஸ் பண்ணும்போது இப்படிதான் பண்ணணும். டோன்ட் திங்க் தட் திஸ் ஆல் டேட்டா given by them. 50 microsecond அவங்க கொடுத்திருக்கிறது diagram with the statements that I am reading. Latching current 100 milliampere and its corresponding pulse length is 50 microsecond. Now what can be the maximum value of R to ensure the firing of thyristor? See, one more thing what you have to observe is, ensure the firing of thyristor means what, sir? Firing of thyristor means, I will tell you the meaning now. See, firing of thyristor in the sense, for an example, there are two things. Let me draw the waveform here. See, why can't go with this given line? It will be better. Wait, see, let me take this one. We will take two graphs here. With respect to time only, both same. Basically, it will be in microsecond practically. So we will keep. First thing, நம்ம என்ன பண்றோம் அப்படின்னா, gate current. I am drawing the waveform. For an example, you have started injecting the gate current here. What will happen? Current flow through the anode to cathode will be started increasing. You all know, slowly it will be keep on increasing. When SCR will turn on, sir, current will be increasing slowly. Current flow through the SCR is increasing. SCR will turn on when this current will be crossing what? Crossing the value of latching current. That is the point. This point is called, this is அப்ப இந்த டைம்ல தான் என்ன ஆகும் அப்படின்னா, exactly at this period. இந்த டைம் ஆல்ரெடி அவங்க கொடுத்துட்டாங்க எக்ஸாம்ல. I mean in your question 50 microsecondல SCR வந்து turn on ஆகுது இல்லையா, latching current வந்து கிராஸ் பண்ணதுன்னு அர்த்தம். So இந்த latching current, இந்த பாயிண்ட்ல latching current ஓட வேல்யூவும் கொடுத்துட்டாங்க. In that 50 microsecond same time period, latching current also given as how much they are given? 1 minute. Yeah, it is 100 milliampere. Latching current is given as 100 milliampere cross பண்ணதுன்னு அர்த்தம். This point is called firing of thyristor. Firing means what? We are turn on. That is thyristor will be turn on. This is called firing. இந்த பாயிண்ட்ல தான் thyristor என்ன ஆகும்? Completely it will be turn on. ஓகே, ஸோ அப்போ இந்த டைம்ல இருக்கும்போது இந்த டேட்டா வச்சு என்ன பண்றீங்க அப்படின்னா, மேக் ஷுவர் ஐடென்டிஃபை தி கரெக்ட் வேல்யூ ஆஃப் ரெசிஸ்டர், மேக்ஸிமம் வேல்யூ ஆஃப் தி ரெசிஸ்டர் ஃபார் திஸ் கண்டிஷன். இவ்வளவுதான், இதுதான் கொடுத்துருக்க கொஸ்டின். ரிமெம்பர் ஒன் திங், இந்த மாதிரி அனாலிசிஸ்லாம் நீங்க தான் பண்ணணும். பட் எனிவே we are in the starting stage of power electronics. I'm doing these things slowly. போக 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 you should start analyzing it. Power electronics will become very easy when you are doing little bit proper analysis. ஏன்னா இங்க எதுவுமே வந்து டீப்பா இருக்காது, டைரக்ட் கான்செப்ட் தான். நீங்க எந்த கொஸ்டின் எடுத்து பார்த்தாலும் பவர் எலக்ட்ரானிக்ஸை பொறுத்த வரைக்கும் அந்த கான்செப்ட் ஆல்ரெடி படிச்சிருக்கீங்களா, அப்படியே நீங்க சால்வ் பண்ணிடலாம். பட் யூ ஷுட் பி வெரி கிளியர் வித் தி கான்செப்ட். லைட்டாக ட்விஸ்டிங் இருக்குங்க கொஸ்டின்ல, அப்படியே கேட்க முடியாதுல்ல. ஏன்னா லட்சக்கணக்கான மெம்பர்ஸ் எக்ஸாம் எழுதுறீங்க, அவங்களுக்கு தேவை வெறும் 100 போஸ்டிங்க. எப்படி உங்க எல்லாரையும் அவங்க எடுத்துக்க முடியும்? அப்போ உங்களில் வந்து யார் ஸ்மார்ட்டா இருக்கீங்களோ அவங்கள தான் அவங்க ரெக்ரூட் பண்ணுவாங்க. பிகம் தட் ஸ்மார்ட் பாய், தட் ஸ்மார்ட் கேர்ள். ஓகே, போத் ஆஃப் யூ. அந்த மாதிரி ஸ்மார்ட்டா நீங்க மாட்டீங்கன்னா ஆட்டோமேட்டிக்லி யூ வில் பி பிளேஸ்ட் அட் தி டாப் பொசிஷன். ஸோ ட்ரை டு பி தி ஃபர்ஸ்ட். First, your rank should be 1. You should be that person. Okay, 2 to 3 minutes you can take. Try to bring the answer. In a question of value of r is dash. Do it fast. Everything is clearly given. ஸோ கொஞ்சம் ப்ராப்பராக அனலைஸ் பண்ணுங்க. ஆர்எல் சர்க்கியூட் அப்படின்னா இண்டக்டர் வழியாக போகிற கரண்ட். அந்த கரண்ட் எப்படி எழுதணும்னு நான் சொன்னேன். இந்த இடத்துல லேச்சிங் கரண்ட்டும் இண்டக்டர் வழியாக போகிற கரண்ட்டும் சேமான்னு ஃபர்ஸ்ட் கவனிங்க. லேச்சிங் கரண்ட்னா என்ன? கரண்ட் ஃப்ளோ த்ரூ தி எஸ்சிஆர். இண்டக்டர் எங்க இருக்கு பாருங்க, அதுக்கு பக்கத்துல பேரலல் ஒரு ரெசிஸ்டர் வேற இருக்கு. யூ மஸ்ட் திங்க் ப்ராப்பர்லி. பிளைண்டா எதையும் பண்ணிடாதீங்க. லாஜிக்கா திங்க் பண்ணி ஆன்சர் பண்ணுங்க. யூ வில் கெட் தி ஆன்சர். RL circuit analysis is little bit required. ஏன்னா நீங்க அந்த எக்ஸ்பிரஷன் எழுதுவீங்களா, ELF எழுதுவீங்க, அதுல என்னென்ன பேராமீட்டர் அன்னோன் இருக்கோ அதெல்லாம் நம்ம கண்டுபிடிக்கிற மாதிரி இருக்கும். ரொம்ப பெருசாலாம் இல்லை, சும்மா சிம்பிளா அதில் எழுதுங்க. அது ஆட்டோமேட்டிக்கா பார்க்க பார்க்க உங்களுக்கு ஆன்சர் வந்துட்டே இருக்கும். Do step by step, you will get the answer. Any answer? You can take 1 or 2 more minutes also. I'll be waiting. No issues. But try to drop your answer. Drop the answer by yourself. Okay. Geeta 2.21 ohm. Ohm or milliohm? I think it will be ohm, right? Okay, very good. Any other answer? Where is putting la? கேல்சி தேவைப்பட்டதுன்னா யூஸ் பண்ணுங்க. ஏன்னா இப்போ ஆன்லைன் எக்ஸாம்ஸில் மோஸ்ட்லி எல்லா எக்ஸாம்ஸ்லுமே விர்ச்சுவல் கேல்சி வந்து கொண்டு வந்துட்டாங்க ஸ்லோலி. So no need to be bothered. Futurely நீங்கள் எழுத போகிற 1 or 2 எக்ஸாமில் மேபி கேல்சி இல்லாமல் இருக்கலாம் அப்கமிங்கில், only for 1 or 2. But futurல every exams will be conducted with, with online calc. Gate calc கொடுத்துருவாங்க. So there is no issues. But practice with the gate virtual calculator. இந்த நார்மலாக இந்த சயின்டிஃபிக் கால்குலேட்டர் காலேஜில் வச்சுருப்பீங்களா, அதை வச்சு கால்குலேஷன் போடாதீங்க. தட் இஸ் ஒன் மோர் ட்ராபேக் யூ பீப்புள் ஆர் டூயிங். அந்த மாதிரி பண்ணிட்டு இருந்தீங்கன்னா டோன்ட் டூ தட். Go to Play Store in your mobile, type Gate Virtual Calculator. அதை டவுன்லோட் பண்ணி அதில் யூஸ் பண்ண ஆரம்பிங்க. Okay, it is in home, ma'am. Done. What about others? Can I expect the same answer from all other? I mean, can I expect the answer from your side also? Okay. I'm giving some clues. It's your responsibility to bring out the answer. Gauri Muthu, 2.22 mega ohm. Good, fine, very good. Any other? Ten power 3. Okay, it means it is in kilo ohm. Fine, no issue. Okay, start பண்ணலாமா? Listen, let me try to bring the answer for this question first. Later you can think about it. First of all, anyway we are going to turn on this SCR. Yes or no? Yes, we are going to turn on. Is there any on-state voltage drop is given for SCR? No, sir. எதை கொடுத்துருக்காங்களா? See, if you observe, last questionல clear சொல்லியிருந்தாங்களா, the on-state voltage drop is 2 voltage for the first SCR, second SCR it is 1.5 voltage. Is there any data like that in this given question? No, sir. They have not given any data like that. So I can say the on-state voltage drop for this SCR is 0 voltage. I am just concluding myself, because they haven't given, so I'm correct. So it will be 0 voltage. First conclusion. அப்போ இந்த SCR வந்து turn on ஆயிடுச்சு அப்படின்னா on-state voltage drop 0 means you can draw its equivalent circuit like this. It will be short circuited basically, like diode. Gate current is there. I'm not denying that it is there only, but I can say there will be no on-state voltage drop. On-state voltage drop SCR la illa அப்படின்னா I can say, see there. Then let me take these two terminals. If you observe the terminals that I am taking, let me call A and B. Between this, we are observing a 200 voltage supply. When this SCR will be turning on, I am observing, will it be, is there any voltage? கண்டிப்பா அவங்க சொல்லிட்டாங்க SCR வந்து turn on ஆயிடுச்சு. அதோடைய 50 மைக்ரோசெகண்ட்ல அவங்க அதை turn on பண்ணிட்டாங்க. அப்போ அதை turn on பண்ணும்போது SCRல என்ட் ஆகிற கரண்டோட வேல்யூவையும் கொடுத்துட்டாங்க. That is 100 milliampere latching current. Everything is clearly given. That current will be flowing like this. Then it will be divided into two parts. Some of the current may be flowing through this resistor R, and some current will be flowing through the inductor RL circuit. That is RL circuit. Let us see how to analyze these things. Now, basically, if you observe, there is one RL circuit, a 20 ohm resistor and 1 Henry inductor, both are connected in series, but they are RL transient circuit. So current flow through that circuit, I am writing it as IL of T. And current flow through the resistor, I am writing simply IR. So if you apply KCL at this point, Kirchhoff current law, what you can observe? The latching current that is flowing through the SCR is 100 into 10 power minus 3. That will be equal to current flow through the inductor IL of T plus current flow through the resistor R. So this is the overall current. Can I write like this? Yes, of course. Now I am repeating one more time. Why when the moment இவ்வளோ இந்த 50 microsecond time வந்து ஏன் வந்து கேட் பல்ஸ் வந்து எடுத்துக்கிச்சு? வாட் ஹேப்பன் தேர்? நீங்க அப்சர்வ் பண்ணி பார்த்தீங்கன்னா சர்க்கியூட்ல ஆர்எல் சர்க்கியூட் கொடுத்துருக்காங்க இண்டக்டர். கண்டிப்பா அந்த சர்க்கியூட்ல என்ன இருக்கும் அப்படின்னா அந்த ஆர்எல் சர்க்கியூட் வந்து சம் டைம் கான்ஸ்டன்ட் வந்து ஆஃபர் பண்ணிருக்கும். அந்த சீரியஸ்ல கனெக்ட் ஆயிருக்கா 20 ஓம் ரெசிஸ்டர் பிளஸ் இண்டக்டர் கொடுத்துருக்காங்க இல்லையா? பேசிக்கலி திஸ் இஸ் கால்ட் ஆர்எல் சர்க்கியூட். This RL circuit will create some transient effect. அப்ப time taken by this RL circuit to reach, அதாவது SCR வழியா 50 milliampere சாரி 100 milliampere current போகிறதுக்கான டைம் வந்து அப்ப யார் வந்து டிசைட் பண்ணியிருப்பா அப்படின்னா இந்த RL சர்க்கியூட் தான். Why sir? Why? Because இதுக்கு parallel வந்து they have connected one more resistor. But resistor basically வந்து என்ன பண்ணாது அப்படின்னா it will accept, resistor alone will be accepting instantaneous changes. So it will not provide any time delay. இதால வந்து எந்த டிலேவும் வராது. Time delay will happen only because of this transient circuit. So time taken by this circuit, SCR வந்து 50 milliampere sorry 100 milliampere reach பண்றதுக்கு இந்த சர்க்யூட் வந்து எவ்வளவு டைம் வந்து கொடுத்திருக்கோம். அப்ப நீங்க என்ன பண்ணணும்? See, நான் ஆல்ரெடி இங்க ஈக்குவேட் பண்ணிட்டேன் பாருங்க. 100 milliampere currentோட contribution 100 milliampere current வந்து SCR வழியா போகும்போது what is the time? அதே டைம்ல what is the time offered by this RL circuit? அதுதான் நீங்க ஃபைண்ட் பண்ணணும். அந்த டைம் क्वेश्चनல கொடுத்துட்டாங்க. Yes or no? That is called 50 microsecond. So I can say the time offered by this RL transient is 50 microsecond in order to let the SCR to reach 100 milliampere. SCR 100 milliampere reach பண்ணும்போதுலாம் RL circuit வந்து எவ்வளவு டைம் ஆஃபர் பண்ணிருக்கு அப்படின்னா 50 microsecond. 100 milliampere அப்படிங்கிறது latching current of the SCR. அப்ப SCR வந்து டர்ன் ஆன் ஆயிடுச்சு. ஸோ இப்போ டைம் எல்லாம் கொடுத்துட்டாங்க. பட் எதை பத்தி பேசிட்டு இருக்காங்கன்னா அந்த பேரலா ஒரு ஸ்டாட்டிக் ரெசிஸ்டர் கனெக்ட் பண்ணிருக்காங்களோ அதோட வேல்யூ வேணும் தான் பேசிட்டு இருக்காங்க. Let us explore. Let me expand this derivation. See, this 100 into 10 power minus 3 equal to IL of t can be written as IL of infinity plus IL of 0 minus IL of infinity. First time இதை பார்க்குறவங்களுக்கு என்னடா இது ஏதோ புதுசா பண்றாரு அப்படின்ற மாதிரி இருக்கும். பட் இது புதுசு கிடையாது, உங்க எல்லாருக்கும் தெரியும். கரண்ட் ஃப்ளோ through the resistor R. இப்படிதான் நம்ம வரைய போறோம். So let us figure out the initial current and final current through the inductors. See, let me ask you. Come back to the circuit. What is the initial current through the inductor? ஏதாவது கொடுத்துருக்காங்களா டேட்டா? கிடையாது. If there will be no data about the initial current, you all know it will be assumed as 0 ampere. So IL of 0 minus 0. What about the IL of infinity? IL of infinity அப்படின்னா steady current, time equal at t equal to infinity. IL of infinity ல almost SCR கண்டிப்பா turn on ஆயிட்டு இருக்கும். கரெக்டா? Yes sir. IL of infinity means you all know inductor will be short circuited. அப்ப inductor வந்து short circuit ஆனதுக்கு அப்புறம் what can be the current that can flow through the inductor? That is the question mark. Nothing is there. At IL of infinity, SCR will be short circuited. That is on state. கண்டிப்பா SCR வந்து ஆன் இருக்கும். Supply voltage எவ்வளவு கொடுத்திருக்காங்க? 200 I think. Yes, it is 200. Now if you observe, all the circuit become parallel. So inductor வந்து short circuit ஆயிடுச்சு அப்படின்னா this total voltage, same voltage will be dropped across this resistor. Same voltage will be dropped across this one. It is always fixed. இந்த R வழியா இந்த Rக்கு across drop ஆயிருக்க voltage வந்து எப்பயுமே 200 தான். Because all are connected in parallel. SCR turn on ஆயிடுச்சுனாலே அது short circuit ஆயிடும். This is the actual circuit. But inductor வந்து என்ன ஆகும் அப்படின்னா we are calculating IL of infinity. IL of infinity means current flow through the circuit at infinity, at t equal to infinity. Now tell me what is the current flow? இந்த ரெசிஸ்டரோட வேல்யூ கொடுத்திருக்காங்களா இல்லையா? It is 20 ohm. Now tell me what is the current flow? See, voltage drop across the resistor is 200. Resistor value is 20. So 200 divided by 20. It will be 10 ampere. Yes or no? 10 times of 20 will be 200. So we found that the value of IL of infinity is 10. So this is 10 plus IL of 0 minus is 0 minus 10 into e power minus t by tau. How will you explore the value of tau? Tau is equal to L by R for the RL circuit. Yes or no? What is the value of L? 1 Henry divided by what is the value of R? R is 20. So tau value is 1 by 20. We found the value of tau also. So we can substitute here later, not now. Plus IR. IR is the fixed current flow through the resistor. இதுக்கு நீங்க RL transient பத்திலாம் பேச வேண்டிய அவசியம் இல்லை. அதுல drop ஆயிருக்க voltage already உங்களுக்கு தெரியும். That is 200. Current flow through the IR. Directly we can say voltage drop across the resistor divided by resistor. So that can be directly written as 100 by R. இப்போ நீங்க அப்சர்வ் பண்ணீங்கன்னா இந்த டோட்டல் கரண்ட் நம்ம யாருக்கு ஈக்குவல் பண்ணிருக்கோம் அப்படின்னா latching currentக்கு. இப்போ இந்த டோட்டல் கரண்ட் latching currentக்கு ஈக்குவலா வரும்போது வாட் இஸ் தி எக்ஸ்பெக்டட் வேல்யூ ஆஃப் R? அதுதான क्वेश्चन. Exactly. Now substitute all the parameter. I had given all the clue. இந்த டைம் வந்து क्वेश्चनலயே கொடுத்திருக்காங்க 50 or 100. 50 microsecond only. 50 into 10 power minus 6, that is the value of t. Tau நம்ம இப்பதான் calculate பண்ணோம் 1 upon 20. அது ரெண்டுத்தையும் substitute பண்ணிக்கோங்க. Substitute பண்ணிட்டு now reduce this expression, estimate the value of r, you will get the answer. Do it by yourself, I'm not going to do that, not a big deal. Okay, I hope you all have understood how to solve this question. இதுதான் நான் சொன்னேன், RL சர்க்யூட் இந்த மாதிரி வரும்போது ரொம்ப பெருசா பயப்படாதீங்க, nothing will be there, எல்லா டேட்டாவும் கொடுத்துருவாங்க. Your responsibility is to observe the circuit in a proper way. Okay, and proper எப்படி analyze பண்றதுன்றது மட்டும் தான் நீங்க வந்து understand பண்ணணும். Then these questions will become very easy. It is not too difficult to analyze this type of questions. Okay, there is one more question. Let me drop that. Same type, but last time I kept only resistor, sorry, only inductor. This time they kept resistor and inductor. This is the given. So what they did here is, this resistor value is 10 ohm, inductor value is 0.1 Henry, and this supply voltage is given as 100 voltage. எல்லாமே only இருக்கு. Now they also told that latching current offered by the circuit also 100 milliampere. Okay, that is not inductor current, latching current. Write it full. Latching current is 100 milliampere. Now as usual, the question is find out the gate pulse time period. Gate pulse width, minimum time taken by the SCR to turn on. So this is the next question. You can do it by yourself. Don't discuss with anyone. Last question